Welcome to my project.com. Now I am going to discuss about the identification of Parkinson's disease using voice signal. Now we see about the concept of this process. Our main aim is to classify the Parkinson's disease voice signal and normal signal. Parkinson's disease is the second commonest late life neurodegenerative disease after Alzheimer's disease. We present a jitter and shimmer feature extraction method for extract the features from the input voice signal. A person with Parkinson's disease has 2 to 6 times the risk of dementia compared to the general population. For finding healthy and unhealthy persons, we use Gaussian mixture model classifier for classification. Our proposed system is able to give the good performance also. This is the flow diagram for the identification of Parkinson's disease using voice signal. Now we are going to discuss about this flow. First, we design the flow for training and testing set individually. The same process is same for both. First, collect the normal voice signal and abnormal voice signal in the dataset. Next step is the pre-processing step. In pre-processing, first load the input virginal voice signal from the dataset. Then the noises is removed from the voice signal by the point average mean filter. From this we get the processed signal. Then next we go to the feature extraction method. In feature extraction, here we use jitter and shimmer feature values to extract the features from the pre-processed signal. State-of-the-art speaker recognition tend to use only the short-time spectral features as voice information. Jitter is the average absolute difference between consecutive periods divided by the average period. Feature vector was extracted from the acoustic system based on the 9 jitter and shimmer measurements. The next step is the classification step. In the classification, we use GMM. It's a parametric probability density function represented as a weighted sum of Gaussian component densities. GMMs are commonly used as a parametric model, the parabolic probability distribution of continuous measurements or features in a biometric system, such as the local trace electric spectral features in a speaker recognition system. GMMs are often used in the biometric, most notably in speaker recognition system. One of the powerful attributes of the GMM is the ability to form smooth approximations to arbitrarily shaped densities. Then GMM classifier is a finite number of Gaussian distributions with unknown parameters. One can think of mixture models as generalizing k-means clustering to incorporate information about the covariance structure of the data as well as the centers of the latent Gaussian. Then the next one is the performance analysis. Finally, to identify the better performance for the voice signal or normal signal or abnormal voice signal. Then finally deduct whether the signal is whose person name. This is the MATLAB command window. These are the files which we used in this process. Voice is the main function file. First choose the voice M file and click the run option. This is the GUI window designed for the identification of Parkinson's disease. First load the input signal. We choose any of the signal from the test set. Then pre-processing step is occur. So if any noise is present in the input voice signal, then the point average mean filter is applied. Then the process is going to be and noise is removed and it's displayed on the next axis. Then we go to the next button. In this, first load the dataset values. Here train all the dataset features. Now we are having 8 signals. So all the signals are loaded in this axis. Then the features are extracted in the table. Then next choose any one of the signal. Then the signal is chosen. Then separately values are extracted for the individual of any signal. Then click the feature extraction button. For 8 signals, the values, actually the testing signal and the train signal, how the signals are placed in this column, that is features. It's displayed in the every graph. Next we go to the GMM classifier. So the classification process has to be done, and we click the classification button if the signal is displayed, whether it is normal or abnormal. Then click the result button. It shows the the progress is in work. The running process is over. Then the 3 graphs are displayed. This graph denotes how the voice is deviated or modulated and represent the individual voice signal, normal signal, as well as the or abnormal signal. Then the name denotes this box. The name denotes whether the signal is which person have that Parkinson's disease. The next way, go to the next button. This is the comparison graph between the previous method and our method because of the performance analysis. Then how much of accuracy we find, and we also get the better performance. In this, red color denotes our process, and the blue color denotes the existing method. Finally, we control that whether the given input signal is Parkinson's disease affected voice or normal voice. Then also get the performance analysis graph also. Thank you.